Okay, we are going to graph some exponential models. Okay, so every chapter pretty much is about one parent function. And this parent function we're talking about is called the exponential model. So it's in general like this. Y equals a times b to the x. This is the general shape of it. The b part is called base. So the b part is the base, which has to do with the exponential model. And then the a part is usually, we call this the initial value. But sometimes it's also the y-intercept, not every single time. Okay, so let's go ahead and graph some exponential models so you can see in general how does this shape look like. So we're going to do an easy one first, which is on the top left, y equals 2 to the x. All right, y equals 2 to the x. Whenever we don't know how a graph looks like, we always take out our xy chart, and then we just put in some x values and plug it in and see how it looks like. So we're going to use -2, -1, 0, 1, 2. Okay, we're going to plug in those x values into the function. First one is 2 to the -2. 2 to the -2. So what should we do to make this number a little bit easier to figure out? 2 to the -2. What should we do when there's a negative exponent?
Flip it.
Flip it. So that is 1 over 2 squared. Okay, once you flip it, the negative goes away. And then we just simplify that, so that is 1 over 4. Right? All right, so let's go ahead and draw our chart. Okay, so when x is -2, y is 1/4. So somewhere there. All right, let's put in -1. 2 to the -1. What is 2 to the -1? 1 over 2. Yes, 1 over 2. All right, so -1 is 1 over 2. Next one, 2 to the 0. Anything to the 0 is what? 1. And then the last two are pretty easy. 2 to the first is 2. 2 to the second is 4. Okay, so 1, 2, 4. And then what we want to do now is just draw a smooth line through that can connect all the dots. So something like that. Okay, be careful with the way you graph this, is that this line cannot go below x-axis on this graph. So this graph is just going to get smaller. The y is going to get smaller and smaller and smaller and smaller, but it's just never going to go below x-axis on this one. All right. Okay, let's try another one. Y equals 1/2 to the x. So we're going to do the same thing because we don't know how this looks like. Okay, first one is 1/2 to the -2. So what should we do? Because the question is, what is that number? 1/2 to the -2. Realize it's 4, it is 4, but how do we get there?
Flip it.
Flip it, Okay, so we're gonna flip it first. How do you flip it? There are a few ways to flip it. That's why I want to see how you guys flip it. Hmm?
2
Huh?
equals 2.
Equals 2. It is not 2.
4.
4. It's 4. But how do you guys flip this one?
1.
Yes, in this one it does work. Okay, what we want to do is flip the entire thing. If it's negative, it goes down, right? Okay, now it tells us that we're going to square it, so it's 1 over 1/4. Okay, 1 over 1/4 is basically saying 1 divided by 1/4. So that means we're going to multiply by a reciprocal. So 1 times 4, which is 4. Okay? Yes? You guys are okay. All right, let's have you guys fill out this rest of this chart and then graph it. All right, so let's look at the numbers. 1/2 to the -1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. And then 1/2 to the second is 1/4. So the graph looks like this. Okay, and then this also doesn't go below the x-axis. It's going to get smaller and smaller as it goes, but then it will not get to 0. All right, next thing, I want you and your partner to talk about these two graphs and these two equations. How are they similar to each other, and how are they different from each other? Okay, so give at least one similarity and one difference. All right, let's see. Andrew and Giselle, one similarity.
We said they had the same shape.
They had the same shape, so it's kind of like a hockey stick, kind of. Okay. All right, Rula and Chad, one difference.
They go like, one of them go to the left and one of them goes.
Oh, okay. So like the high part, one goes to the right and one goes to the left. Okay. All right. Sebastian and Andy, one similarity.
They both have 0, 1.
They both have 0, 1 as the y-intercept. Good. How about Alice and Alana? One difference. Or one similarity, if you can't think of any difference.
They both go below x.
Yeah, good. They both don't go below x-axis. Can you guys think of anything else that's similar or different between, maybe not just with the graph, maybe with the equation? How are they similar or different in the equation? Yeah.
So for like y equals 2, x they're opposite. So -2 equals 1/4 for the first one, but on the second one, -2 is just.
That's good. So basically, you can see that the numbers are kind of like reciprocal of each other, right? And then basically, they're flip of each other across the y-axis. Okay. What do you guys notice about their equation? What's similar about their equation? Where is x?
The exponent.
Yeah, x is in the exponent, which is why this is called an exponential graph. So this is now in the exponent. Everything we had done in the first semester is x not in the exponent, x squared or like square root x or something like that. This time we have x in the exponent, so that's very different. Now, if you look at these two numbers or these two graphs, 2 to the x goes up, 1/2 to the x goes down. Why do you guys think that is? Has something to do with that number, right? That's the only difference. Okay, so when b, which is the base, is greater than 1, it is exponential growth. Exponential growth. For example, you guys pretty much took biology before, right? Okay, so, yeah, no? Okay, so let's say that you have a petri dish and it has one bacteria inside. And then you know that this bacteria is going to divide itself every hour. So you start with 1. The next hour it divides, so it becomes 2. Next hour it divides again, becomes 4. Next hour it divides again, becomes 8. Next hour, 16, 32. So it keeps doubling, right? So by the end of the day, 24 hours, it will be a lot of bacteria. So that's why don't split on somebody. You don't want the bacteria to get on and then it just multiplies. Okay, anyways, exponential growth means it divides, and then it just gets really big, really, really fast. So something like bacteria growth. All right, when b is between 0 and 1, it is exponential decay. Do you guys know what decay means? What does it mean?
Like, whittle away.
Whittle away. So basically, it just like gets less and less. So exponential decay means that something is going to drop down really, really fast until it's almost like nothing. For example, like this year, a lot of you are in chemistry, right? You know, in chemistry, you have your periodic table, right? Periodic table has this section in the middle. Do you guys remember what it's called?
Transition metals.
Yes, the transition metals. Good job. Okay, transition metals. Why are they transition metals? Or radioactive elements? Because they cannot survive for more than a certain amount of time. It's man-made. Like if you make it, it stays there for however long it does, and then it goes away. So that thing. So for example, if you have a radioactive element, it decreases its amount by half every hour. So you start with 1, like this element. Next hour, it's half. Next hour, it's 1/4. Next hour, 1/8, 1/16, 1/32, and so on. Until it's so little, it's almost like it's gone, but it's still there. So that is an example of exponential decay. So radioactive element. All right, and just a reminder, what is y-intercept? Y-intercept is when x is 0. All right, we're going to do some practice. You are going to figure out which one is exponential growth, which one is exponential decay. Remember, you're looking at a base. And then you are finding the y-intercept. Okay? 1, 2, 3, 4, 1, 2, 3, you're going to circle whether you think it's a growth or decay, and then what is the y-intercept? All right, let's start with Evan. Number 1, growth or decay? Huh? Growth? Oh, no, not growth. It's decay. Nathan, did you write decay? Okay, why is it decay?
Because the base is 0.95, which is in between 0 and 1.
Yeah, so base is the number that's right next to x. Okay, Isabella, what number did you get for y-intercept?
1.
Oh, not 1. Y-intercept is when x is 0, so when this is 0, this is 1, so it's 12. Yeah, or for the most part, you can just look at a, which is the number that's next to it. All right, number 2. Daniel, is it growth or decay? Good. Why is it gross?
Because it's bigger than 1.
What number is the base?
2.
Yeah, good. So base is 2, which is greater than 1. All right. Josh, what number is the y-intercept?
Uh, 1 over 2.
1 over 2, not 1 over 2. Y-intercept is when x is 0.
A 1.
Maybe Samantha can help. Did you get the y-intercept?
Yeah,
Uh,
0.25.
0.25. So basically, it's the number next to it, which is just the a. All right, Brady, you get the hard one. Growth or decay? It's actually really hard. Decay. That is correct. All right. So some of you may look at it and say it's growth. That I understand because you see the 2, but it is not growth because this is not in the right form. So 2 to the negative x, we have to change it into the correct form, which is 2 to the negative 1 times x, right? Negative x is just negative 1 times x. It is the same as saying 2 to the negative 1 to the x. And kind of going backwards from last chapter. So this is the same as 1/2 to the x. So then the base is actually 1/2, which means it's going to decay. Mark, did you get the y-intercept? No, you're not yet? Okay. Sally, did you get the y-intercept? 1. So basically, you can plug in x equals 0, or you can look at it and say 1 is next to it, 1 is a, so that's the y-intercept. All right, now let us solve some word problems. You invest $1,000 in savings account at the end of 6th grade. The account pays 5% annual interest. How much money will be in the account after 6 years? Okay, so this is a question where we're going to do a times b to the x. We're going to have to figure out which one is a, which one is b, and which one is x. Or it could be y also. You invest $1,000 in the savings account. So what I want you to do is talk to your partner. Is $1,000 a, b, or x? All right, let us vote. How many people think it's A? How many people think it's B? How many people think it's X? Okay, well, let's look at $1,000. You invested $1,000 in the savings account. So $1,000 is how much you start with, which is the initial value. So A is 1,000. All right, next one. Trick question. 5%. 5%, is it B or X? It's a trick question, actually. It is not quite B, but it should be in B. What happened? Okay, well, you are investing $1,000, so are you getting more money back or you're losing money? Like after 6 years, are you going to have more money or are you going to have less money? More money. Okay, so that means you start with $1,000. You're not going to lose that $1,000, right? Yeah, you're not going to lose the $1,000. That means you start with 100%. And then you get 5% every year. Okay, so that is 105%. So we have to change that into a number and not a percent. So 105% is what in number? Oh, not 10.5. Wait, did you say 10.5? No, you didn't. Okay. What is 105% in decimal? 1.05. All right, last part. How much money will be in there after 6 years? So 6 years is what? X. All right, so this is 1,000 times 1.05 to the 6th power. Okay, you need to take out your calculator and calculate this, because you need to figure out where that button is to do this calculation. Very important thing to notice. We have to make sure you follow PAMDAS. PAMDAS says the first thing you do is parentheses. Is there parentheses? No. The next thing you do is exponent. Is there exponent? Yes. We have to do this exponent first. What's the next thing PAMDAS says to do? Multiply. Now, once we figure that out, then we multiply by 1,000. Do not multiply 1,000 and 1.05 first. That would be wrong. PAMDAS says exponent first. Okay, so you're going to take your calculator and do 1.05 to the 6th power. If you don't know how to do that on the calculator, please let me know. I will help you. All right, Blake, what'd you get for the answer?
1,345.
Okay. All right, let's try another one. A population of 5,000 decays at 2% each year. How many people are left after 5 years? Okay, A, B, X. All right, once you write down what you think A, B, X are, please talk to your partner and check if you guys have the same answer. B is the critical part. B is a little bit tricky. Allison, what'd you get for A?
5,000.
Good. Trey, what'd you get for, let's do X. What'd you get for X?
5.
Good. Okay, B. What'd you guys get for B? How many people had 102%? How many people had 98%? 98% is correct. Why is this 98% and not 102%? Decays, it's losing people. So we have to start from 100% and then minus 2%, which is 98%. All right, go ahead and figure out the answer. Let me know when you're done. Okay, Terry, what'd you get? How many people are left after 5 years?
4,598.6.
Okay, so around 4519 or 4520. So either one is okay. All right? All right, that was not too bad, but that's kind of like an introduction to exponential equations. We are now going to talk about transformation of these exponential equations, which is pretty easy. All right, let's look at this. So A times B to the X is the general form of the exponential equation. Now we have to remind ourselves what all these things are. First of all, we have to figure out where the parent function is. Parent function is B to the X. Base to the X, that is the parent function. Okay, B to the X. All right, let's hopefully remind ourselves what these letters mean. Okay, Sam, what is A? What does A do? Do you remember? No, not at all. Okay, let's go to Andrew. What does A do?
AB.
Just A.
What to say? What's it called? It's the one that stretches out. Remember the name?
Yeah, just stretch or compress. Okay, Giselle, do you remember what H does?
Moves left to right.
Yeah, left and right. And then Rula, do you remember what K does? Up and down. Okay, so what we're gonna do is look at the following problems. We're going to figure out, first of all, where is the parent function, and then the next thing is what's the transformation? Sorry, you guys are still copying this down. So we're gonna look at number 1 together. All right, number 1. Y equals negative 1/3 times 3 to the X. What is the parent function? What do you guys think? 3 to the x. 3 to the x is the parent function. Okay, then that negative 1/3 is the transformation. Okay, so what's the first transformation or one of the transformation? Compressed by 1/3. Okay, and then the other one, someone else?
Reflect x-axis.
Reflect x-axis. Okay, and then we'll graph this together later. All right, let's have you guys try 2 and 3. So you are going to first figure out what is the parent function, and then what is the transformation. All right, let's look at this. Number 2, Chad, what is the parent function?
2 square root x.
2 square root x? 2 to the x.
Yeah, 2 to the x.
2 to the x. Okay, good. So then, Sebastian, what is the transformation? Right 4. Okay. B to the x is the parent function, so don't get confused there. 2 is not a stretch 2, okay? Number 3. Alana, what is the parent function? 1/2 to the x, and then I skipped Andy, I forgot. What is the first transformation? Yeah, stretch 2. And then, Alice, what's the second transformation? The plus 10. Up 10. Yeah. Okay. All right. So let us graph this. Let's do number 3 because this is probably the trickiest one. So what you're going to do is you're going to stretch 2 and then go up 10. Okay? So you're going to you can either start with the parent function and then just stretch 2 and go up 10, or just put in some values. 2 times 1/2 to the negative 2 plus 10. Make sure you do each one separately. So do the 1/2 to the negative 2 first, whatever that number is, times 2, and then add 10 to it. And then go ahead and graph that one. Let me know when you're done. So this is 18, 14, 12, 11, so on. So it's gonna look like something like this.